Welcome back to episode 6 in our examination of relational database systems and relational database constraints. For over the last video or so, we've been talking about constraints that apply to relational databases, and we're going to continue with that for a while. In this video, we're going to discuss some more explicit constraints that apply to relational database. So let's get started. The preceding integrity constraints are included in the data definition language because they occur in most databases. However, they do not include a large class of general constraints, sometimes called semantic integrity constraints, which may have to be specified and enforced on a relational database. Examples of such constraints are: the salary of an employee should not exceed the salary of the employee's supervisor, and the maximum number of hours an employee can work on all projects per week is 56. Such constraints can be specified and enforced within the application programs that updates the database or by using general purpose constraint specification language. Such constraints can be specified and enforced within the application programs that update the database or by using a general purpose constraint specification language. Mechanisms called triggers and assertions can be used. In SQL, create assertion and create trigger statements can be used for this purpose. Another type of constraint is the functional dependency constraint, which establishes a functional relationship among two sets of attributes. This constraint specifies that the value of one attribute determines a unique value of another attribute in all states of a relation. It is denoted as a functional dependency. We use functional dependencies and other types of dependencies as tools to analyze the quality of relational design and to normalize relations to improve their quality. The types of constraints we discussed so far may be called state constraints because they define the constraints that a valid state of the database must satisfy. Another type of constraint, called a transition constraint, can be defined to deal with state changes in the database. An example of a transition constraint is the salary of an employee can only increase. Such constraints are typically enforced by the application programs or specified using active rules and triggers. The operations of a relational model can be categorized into retrievals and updates. A relational algebra expression forms a new relation after applying a number of algebraic operators to an existing set of relations. Its main use is for querying the database to retrieve information. The user formulates a query that specifies the data of interest, and a new relation is formed by applying the relational operators to retrieve this data. There are three basic operations that may change the states of relations in the database: insert, delete, and update, or modify. They insert new data, delete old data, or modify existing data records. Insert is used to insert one or more new tuples in a relation. Delete is used to delete tuples, and update is used to change the values of some attributes in existing tuples. Whenever these operations are applied, the integrity constraints specified on the relational database schema should not be violated. Let's talk about the types of constraints that may be violated by each of these operations, and the types of actions that may be taken if an operation causes a violation. We're going to use the database shown over the next couple of slides for examples and discuss only key constraints, entity integrity constraints, and referential integrity constraints. For each type of operation, I'll give some examples and discuss any constraints that each operation may violate. One possible database state for the company relational database schema includes the employee relation, the department relation, and the department locations relation. Note that the employee relation contains 10 attributes, including SSN, which, as you can see by the underline, has been identified as the primary key. We see that the department relation has 4 attributes, including department number, which is the primary key. We also notice that the department locations relation has 2 attributes, both of which are underlined, which means that the primary key is actually made up of 2 attributes, not 1. And as we can see from the tuples that are in there, it's absolutely necessary. We see that a department number 5 is in 3 separate tuples. And we see that Houston, the location, is in 2 separate tuples. So neither one of those attributes alone could be the primary key. But by making them both the primary key, no 2 records are identical. Now then, as far as the insert operation is concerned, inserting a new tuple into the employee relation would really have no impact on anything other than provide new information that's there. The only issue is that the new tuple that we add must be unique, which means that it must have a different social security number than any of the others. If we try to insert a new tuple without a social security number at all, that would be a violation of that constraint. A primary key cannot have a null value. If we were to insert a new tuple in the department table, well, there would really not be any impact to the database either. A couple of caveats to that are that if we put a manager social security number, which manager social security number is in fact a foreign key related to the employee table, so one of these employees would be the manager down here. Let's take a look. I see 3344555, and if I look up here, that is Franklin Wong. 987654321, that is Jennifer Wallace. So if we add a new tuple to the department relation, the new tuple would have to have a social security number that matched one in the employee relation, or according to the rule of referential integrity, it could be null. It could be blank. The same can be said for the department locations table. The department number here must exist over here. But in this case, the department number cannot be null. Why? Because it is part of the primary key of the department locations relation. Well, we've covered quite a bit of material here. So why don't we take a break? Let's see, we haven't discussed a mystery word yet, have we? How about foreign key? Let's make foreign key the mystery word. So let's take a break and submit our mystery word, and then go out to the coursework area and check our knowledge on the material we just covered. In the next episode, we're going to tie up the loose ends, and because of the importance of the issues we've been talking about, we may rehash this video also a little bit more. See you when you're ready to come back.